As I said at the beginning, we're breaking this down, and so we're going to start this exciting and dynamic section on healthcare. And we have two very well-known folks who are sitting in front of us. Craig Venter, who really for now decades has been studying through the Institute genomes and what needs to be done and what kind of innovative and transformative things can happen in the healthcare system. And Nancy Snyderman, who is the Chief Medical Officer of NBC, also spends a lot of time focused on looking forward and what is the next stage in innovations and what can we really do to build a healthier population. So with that, Nancy, I will let you take it away.
Thank you. Craig and I You have the microphones? Oh, we don't. So we were just having this conversation. Do you know how to use the microphone? No. Do you know how to use the microphone? Really good. A physician scientist and a well-known PhD. So here we go. What don't we know about you that you think is germane? We know a hell of a lot about you.
Yes. Apparently I need to.
Let me see. Does that work?
There we go.
Okay.
So a lot of people were very concerned when my genome was the first one sequenced that we were putting it on the internet.
The entire federal government.
That it would disclose everything about me. But I also, I wrote an autobiography that actually revealed far more than my genome has revealed, in part because we don't know how to interpret the genome yet. And so I think that's a big challenge for this next phase of medicine, is to get it so we can understand what each of our genetic code will tell us. And
it was very interesting because I was already, as a surgeon reporter, I remember in 1998 when you started Celera. I remember when you published in Science the genome. I also remember the race between the private sector and the federal government. And then, of course, we know all about Henrietta Lacks, which brings me to the question of the role of the private sector and the federal government, how and should they work together, and who owns what these days?
Well, how they should work together is they definitely should work together. And it's an increasing challenge as private industry keeps taking over more and more of what was assumed to be the role of the federal government. And I can't think of a better example than the wonderful accomplishment we just saw with SpaceX. So the first private rocket actually going up and docking with the space station just splashed down about an hour ago. That's something that we had to have our multi-billion-dollar NASA program to do in the past. We did it with the human genome. They've done it now with starting to take over space. Private industry can move about 10 times the pace that government seems to be able to move. And when I left NIH, I was at NIH for almost a decade, the same money went 3 times as far in private industry than it went in the government and the efficiency. But at the same time, there's long-term processes. Here in New York with the stock exchange, most people have a vision of 3 months. The governments have a vision of probably 2 years or at least an election cycle. So to get to the really long-term accomplishments that we need, we have to have both. We'd like the government to be funding things that are really long-term, visionary, changing things while industry fills in and makes it happen.
I know that you're looking at genes beyond the human being. And of course, today on the front page of the New York Times, an article about the genetic makeup of the tomato. And the tomato has more genes than a human being. Can you please explain that to us?
Well, tomatoes are smarter than some people I've met.
Does that mean we should be multiplying more, or we figured out which genes we don't need? Or
well, it was actually one of the biggest notions in 2000 with the first look at the human genome. Everybody wanted there to be a very large number of genes because that seems to correspond to the number of traits that we might have. And biology doesn't work that way. It's the combinatorial nature of we have 100 trillion cells. So 20,000 genes on 100 trillion different combinations is a very big number. Plants actually have the largest genome. The largest one we know of is the lily, which is roughly 91 billion base pairs versus our 6 billion. And maybe lilies get the last laugh because they end up on our graves. But the number of genes really does not matter. In plants, there's lots of duplications where the genome gets duplicated over and over again. So the number of genes is not that meaningful.
Talk to me about the field of epigenetics. I know the history of people who were born to moms and dads who went through the Irish potato famine and the risk of cardiovascular disease later. But how do we trump our genes? When can you trump your genes? And when should you try to trump your genes?
Yeah, those are all great questions that we would need hours to get the real answers to those. But there's a thing in terms of DNA can be modified, usually by methylation, adding just a methyl group. Controls to some extent whether the maternal genes or the paternal genes actually get expressed. So you can get things passed on that way versus straight genetics. And there's a lot of modifications from the cell post the genome. But everything starts with DNA, and everything in the cells is made from what that DNA instruction does. And that's what we just proved in 2010 with the first synthetic cell, by completely making the genetic code from 4 bottles of chemicals and showing everything in the cell derived from that DNA that was synthetic.
So if you are born to parents who are unhealthy, let's say 2 morbidly obese parents, but you're born skinny, does that mean that the epigenetics of 2 morbidly obese parents having you may have changed, in fact, your DNA?
Well, it's really hard to sort out because social evolution is changing so much faster than genetic evolution.
Yeah.
And the environment, just being in a family with obese parents, would have somebody even with a completely normal genome have them much more likely to be obese than if they had 2 thin, super healthy parents. So it's very difficult, and that's why we need very large numbers. So to get so we can interpret the genome and actually have the answers to some of these questions, we need at least 10,000 human genomes and all the corresponding phenotypic information. So you're a physician, imagine recording everything about your life, everything about your physiology, how your brain works, all your chemistry, your whole medical history, and having all that information digitized along with your genetic code. And if we do that a minimum of 10,000 times, we can start to have a database that makes the data interpretable. Probably 1,000,000 times is going to be a whole lot better. But genetics is statistical. There's very few yes-no answers in your genetic code.
So that brings up sort of the future of your field. In the privacy issues, I could hear some mumblings in the crowd, but if you know your genome, increasingly the private sector is getting into the human genome. What does the average person own or have the right to own in his or her genome versus the scientist who figures it out?
Well, less and less all the time. And I started a trend, and I think it's been nicely followed, being the first one just to make my genome freely available on the internet, showing that there's a whole lot less to be feared than people imagine. There was a lot of fear built up that based on genetic determinism, you are your genes. We can look at your genome and predict everything about you. You'll know your future.
Breast cancer in your family, therefore
Right.
we won't employ you,
That's
and
right.
et cetera.
It just doesn't work out that way because of the statistical nature of biology. Identical twins have different fingerprints, even though they have exactly the same genetic code. When you go from 1 cell to 100 trillion cells, there's so many random events that take place that identical twins are truly not identical, other than in their genetic code. So to try and understand the role of genetics and how all these different events take place, we need very large numbers, very large databases, and hopefully all the information would be public. People should have the option to keep it private if they want to. But as you know, privacy in the field of medicine is an illusion, not a fact. And so most medical information is not private now. Everything you have gets shipped off to your insurance company, whether you want it to or not.
Well, I'm always amazed that people are worried about privacy, but then share the most unbelievable things on Facebook. So if you could sort of have a panacea and create an environment, would you ask for 10,000 or 1,000,000 volunteers to say, let us get your genomes, put it in an international registry, and then share that information with other scientists?
That would be the ideal for the world, but that's a very expensive proposition.
So what's then, what can you accomplish?
So I think what's likely to happen is private industry will fund new enterprises to do this. And those databases may be private databases, but the predictions that come out of it will create huge amounts of value. If we want it all just to be in the public domain, which is not a horrible idea, the taxpayers have to put up the billions of dollars to actually do that. Although it costs less to sequence 10,000 genomes than the government paid for the very first draft that was done. So the technology has changed immensely over the last decade. We had a room roughly this size full of giant machines to sequence the first genome. Now it's something that would fit on a small desktop and does the job in a couple of hours for $1,000 or so.
And is it fair to say that the more you do it, the faster it's going to get, the less expensive it's going to be, and the more information you'll have?
Ultimately, instead of you paying to get your genome sequenced, companies will pay you to have all your data in the database because it adds value to the database and makes it more predictable for the rest of the world.
But let me take you back to the Henrietta Lacks story, because it's now a famous and infamous tale of people who became very wealthy and, yes, made a lot of innovations from a woman who really never knew anything about it, which takes me back to the ownership issue, and I think sort of the crux of the moral and ethical dilemma. Where do you draw the line?
Well, I think everybody has a right to control where their cells and tissues go. Although you can, from several repositories, you can download, you can get cell lines made from my skin tissue and things, because it's very helpful to use these for research. And I think the HeLa cell contribution, even though a few people got rich off it, what the contribution was, it really changed science across the board. So it's sort of a side story whether somebody got rich or didn't. And people are always worried about this, that this is a problem with countries around the world worrying about more who gets rich off of the information than the true value for the world. Our expedition has been taking samples in the oceans around the world. Darwin could not have done any of the work that he did today. We have to get permissions. We work through the State Department. We get permissions and permits from those countries just to take a barrel of seawater. Right. Because the worry is who owns this stuff, and we just want to put all the data in the public domain. A lot of countries now don't want the data in the public domain because they think somebody can get rich off it. So it actually complicates basic science immensely. And
is this your greatest frustration right now?
No, my greatest frustration is not having enough time in the day to do all these things. But,
that brings up an interesting comment. We were just talking before we got up here about the fact that everyone needs quiet times to think, because that's where the big ideas come. And when you're racing around the world, you don't have time to really be creative. Let me talk about your hope for the future, because you and I probably have more ideas now than we realize we will be able to fulfill in a lifetime. Do you find that you're thinking about great ideas, but you recognize that your runway on this earth just gets shorter at the same time that your brain is exploding with more ideas?
It's tough to hear that from a physician, but thank you for pointing it out.
Well, I just want to remind you that you're mortal, because I know some people here think you're not.
Yes, I do worry about it. I turned 65 last year, and
congratulations!
And so it's a question of
it's a weird number, isn't it?
Yes, of getting through all the things that we're trying to accomplish. But two of my best colleagues in science, Ham Smith, who got the Nobel Prize in 1978, just turned 80 last year. See? And Clyde Hutchinson turned 75 this year. So they're still working every day in the lab. And
can you imagine not working?
No.
I can't either.
Yeah, it's retirement. If you have a labor job and you're just working for money to have the rest of your life, I can see wanting to retire. My job is one of the most privileged jobs in the world. I ask questions about life and get paid to try and answer them and go around explaining that to the rest of the world.
See, I think I have the best job in the world because I get to interview people who are smarter than I am, and then I always walk away having learned something. So there you go. It's a win-win.
Yes, there's no retirement. So I will die with my lab coat on.
So what makes you hopeful about tomorrow?
Well, I think...
and I say that because you mentioned a second ago the social issues. the diabetes and obesity issue is now global. We've talked about epigenetics. There seems to be so little hope in the social aspect of health and wellness. But you're always ebullient about what's happening on a cellular level.
Yeah. Well, you can't be a scientist and not be an optimist. Because if you're a pessimist, you'll never do the experiment in the first place. You'll just assume it won't work and you won't do it. So I've argued that optimists and pessimists, you never know who's right, but the optimist will at least do the experiment to find out. But there's so many challenges, and we're adding another 1 billion people to the population in the next 10 years. So basically the equivalent of China being added again to the earth. And we can't provide enough food, water, fuel, medicine, housing for all the people that are here now. We passed 7 billion last October. 10 years from now, we're going to have 8 billion people. And so what we're trying to use is our new disruptive technologies of synthetic DNA to design cells that can make fuel, can make food from sunlight and carbon dioxide. We're making vaccines now. You know how long it took to get the H1N1 vaccine out when the pandemic started. We're working in private-public partnership with the U.S. government, with BARDA, with Novartis, and we've gotten down the time. So BARDA sends us an email with a new pandemic sequence in it. We make that new virus in less than 12 hours.
Really, 12 hours?
We get that to Novartis, and they have a massive facility in North Carolina using MDK cells to, they could produce enough vaccine in a short time for the entire nation. So the process using these new tools is changing overnight. It's a combination now that biological information is digital. All you have to do is send an email with the digital information. It's like the new printers. We can print the DNA and make new viruses, new cells to do what we want. But we have to have new technologies. We're now in a society that is 100% dependent on science for its future. It's not an option, it's not a luxury, it's not nice to know things. Without new science, new breakthroughs, we don't have much of a future because we're destroying our environment as we go.
Do we have enough of a pipeline of new scientists?
I think we do in this country, and we certainly do coming out of India and some parts of Asia. China is trying to come up very quickly to speed with some amazing scientific breakthroughs and teams. What I worry about most in our country is there seems to be this new anti-intellectualism, anti-science attitude that's developing that's going to take us backward and make us non-competitive as a nation and not able to solve the problems we have to solve.
So, I mean, you and I are both pro-vaccine people, and I agree with you that, at least in the United States, a lot of the science has been hijacked, and it puts us in a very dangerous place. With that said, what's the message to those who don't understand how science can make the future better and stronger? How would you sell it if you had to?
I mean, I think it has to start fundamentally with evidence-based decision-making. And we've seen in recent years in politics that people don't like the facts, they make up their own.
Like you're entitled to your own opinion, but you're not entitled to your own facts.
And there was this one case where Sarah Palin's advocates were trying to change Wikipedia definitions of what Paul Revere did to match what she was saying. You know, we have to have respect for fundamental knowledge, things that have gone through this process of creating the fundamental knowledge. And it's not just, you know, changes with political whims, what those facts are. And if we start with that and start with evidence-based decision-making, it gets applied to all aspects of life. You know, people want to find explanations of why there's more autism. People want to have control over their own medicine. I think that's where genomics will help. But we have to get it out of sort of the witchcraft mode of, well, it must be vaccines today or, you know, whatever the latest thing is. Because people are just going to limit themselves. You know, diseases, as you know, are starting to rise again that we thought we had eliminated because people are stopping vaccinations of their kids. And this is not just a social economic thing. I've traveled with billionaire families they ask these same questions, should they vaccinate their kids? I mean, it's really stunning. Steve Jobs died from ignorance. The guy with, access to money, knowledge.
Had a curable cancer.
He had a curable cancer, and he died from not dealing with modern medicine. So how to have that knowledge and that way of learning things be widespread, I don't have the answers to those questions.
But you're hopeful.
I can only be hopeful. And I think there are new solutions, and if they're adopted, they'll affect the majority of the populations. There's no way to get everybody to agree on everything, but that's how evolution works as well.
I believe in you.
Thank you.
Thanks, everybody.
Thank you.